Okay, in Unit 8, this is our one geometry unit that we do the entire year. Okay, so that's why it's it's a little bit bigger. It's just we put it all into this one unit. Okay, because really the only couple things that we're talking about in here are reflections, translations, and rotations. Okay, so we're going to look at those on a coordinate plane, but before we do that, we have to kind of understand what they are. So we had those three types. Okay, which one of those three would the butterfly show? Which one of those symmetries? Yeah, they all have symmetry. All three of these have symmetry. But I want to know, of the three that we talked about, what does the butterfly show? Okay, reflection. The butterfly shows reflection symmetry. A reflection is like a mirror image, right? And on the butterfly, okay, one side is the mirror image of the other. Going straight down the middle. Okay, the fan shows what kind of symmetry? Rotational symmetry. Because if you rotate it, it's the same thing. Okay, if I rotate this blade to this blade, it would be the exact same picture, right? All I would do is rotate it around, and it's going to be the same picture. Okay, and then the wallpaper at the bottom with the fish shows what kind of symmetry? Translation symmetry. And a translation, another word for a translation? Okay, a slide. You're going to slide it. So I'm going to slide this fish over, and it's going to be the exact same. Slide it again, it's the same thing. Translation is a slide that you do over and over. Okay? Next page, the first one we're going to talk about for the next couple days is reflection symmetry. Okay? Reflection symmetry is, again, when we can fold something over and it's going to be the same on each side. Okay? And you're going to find many different lines of symmetry where you can fold it so that it's the same thing. Okay? So if I look at this banner here, is there a line of symmetry where I could draw a line or a diagonal line or any line? If I fold it over that line, it would match the exact same thing on that one? Okay, give me one. Down the middle vertically. Okay, so I would have to, as best as I can, get it in the middle as best as I could. And then if I fold over that line, okay, and that's not the best, obviously, line that I've ever drawn. Okay, if I fold over that, am I going to have everything right on top of each other? Yes, we are. Okay, how about, is there any other? Okay, diagonally in a rectangle, you can't do that. Because a rectangle, diagonally, is not going to give you everything exactly the same. In a square, it would. In a rectangle, it does not. Okay? So diagonally doesn't work. Is there another one? If I draw horizontally, it will give us one as well. Okay? So horizontally in the middle would be another line of reflection, and I didn't get it quite where I wanted to, but the idea. Okay? Are there any others? That's it for that one. Okay, let's look at the second one. It's a square that's turned off to its side. Does anybody see one line? Yeah. Okay, where, Brooklyn? Up and down vertically. Okay. Any others? Evan? Horizontally. Oops. Any others? Now you can go diagonally because it's what shape? A square. And a square you can go diagonally. And then I could go diagonally the other way too. Okay? Any others? How many lines of symmetry does this shape have? 4. 1, 2, 3, 4. Okay? So that one's got 4. How many did this one have? 2. Okay? How about this shape? If you don't look at the feet, the arms, and the head, okay, could you draw a line of symmetry anywhere? Can draw diagonally. I could do what though? I could cut it right here, and that would take this and flip it right on top of the other one. Okay? It would flip this triangle right on top of this triangle. It would flip this triangle and this triangle and this triangle and that triangle. Okay? Are there any others? I don't see any more, so how many does this one have? Okay? Down here, the pentagon. Okay, you can draw it vertically. I can't go horizontal. That is not it. I can go diagonal from each of these points. Okay? From each of those points, I can go diagonally. Because it's a pentagon, so all of those are the same distance apart from each other. Okay? And because you could draw this one and flip it halfway over there, it's the same shape if you just turn your head sideways and look at it a different way. It's always going to be that same shape. So how many lines of symmetry does that one have? 1, 2, 3, 4, 5. Okay? How about the isosceles triangle that is next? Just the vertical line. Okay? And that's going to be it because these two sides, this side is longer than these two sides. Okay? So I couldn't draw here because this is longer than that side. Alright? This side is longer than these two. So therefore I can't draw that diagonal because this is too far. Okay? So, how many lines of symmetry? 1. Any questions on drawing lines of symmetry? You're trying to picture, okay, in this unit, a lot of it is picturing it in your head. What would it look like? Can I take half of it, flip it over, and it's going to be the exact same on the other half? Okay? And that's what we're going to be looking at a lot of. Okay, and then we're going to look at some rotational symmetry. And when you talk about rotational symmetry, you're going to tell me how many degrees do you turn something so that it's the same. Okay? You could turn something 90 degrees. I could turn something how far? 72 degrees. Up to 360 because a full circle all the way around is 360 degrees. So if I look at this star, how many points does that star have? 8. Okay? So how many times could I turn that star and it's going to be the same thing? 8 times. If I turn it 8 times, if I start at this point and I turn it, that's 1, 2, it would be the same, 3, all of these points, I would turn it until I get back here and I would turn it 8 times where it's going to be the same. Okay? Now, the angle of rotation, any ideas of how I might find what that degree measure is? Alex? Very good. 360 divided by how many times you could turn it and it's going to be the same. Okay? So you might want to write that down somewhere. To find the angle of rotation, It's 360 divided by the number of times it can be turned. Can be rotated, I guess. And in this case, how many times can we rotate it? And it's going to be the same? 8. So I do 360 divided by 8, and I get my degree measure. What's 360 divided by 8? 45. Very good. 45 degrees. Okay? 360 divided by 8 is 45. Yeah, you want to fill a pass, correct? Does the windmill have rotational symmetry? Okay? It does. How many times can you turn it and it's going to be the same thing? 4, yep. Okay? So does it have rotational symmetry? Yes. What is the angle of rotation going to be if we can turn it 4 times? 360 divided by 4, not 45, 90. Okay? So if I turn it 90 degrees, it's going to put this arm right on top of this arm. And then I turn it 90 degrees again, I'm going to put this arm right on top of this arm. And then 90 degrees again, this arm on top of that arm. Okay? So I could turn it 4 times. That means 360 divided by 4, and we get our 90 degrees. Okay, where's the center? Okay, right in the middle. Very good. Does it have reflection symmetry? Does it have reflection symmetry? Okay, so reflection symmetry is when I need to draw a line and see if I could. Okay, now if I flip that over, is that the same thing? Yeah, they're sticking out on the wrong sides, right? Thank you. Okay, they're sticking out on the wrong side, so this one does not have reflection symmetry. Okay, because the arms aren't quite the same. Okay, then translation symmetry, the last one. When we talk about translation symmetry, I want the only things I want you to tell me is the direction it moves and how far it moves. Okay? So there's 2 things when you talk about translation. Okay, and you might want to put it somewhere. There's 2 things that you have to tell me. Okay, you have to tell me direction, and you have to tell me how far. Those 2 things. When you talk about translation, tell me which direction does it move and how far does it move. Okay? So we look at wallpaper. Wallpaper is a perfect example of translation symmetry because it basically takes this one shape and copies it a lot of times, right? Okay? So maybe you wanted a palm tree wallpaper in your bedroom. Okay? So I get a picture of a palm tree and I just copy it over and over and over again. Okay? So which direction could you tell me this moves? Okay, it could move right. What if I start over here? Okay, you just have to find one starting point and then draw an arrow to show me which direction it's moving. So maybe I start here, I draw my arrow this direction. Okay? Maybe you're a bike rider. You want to be in the Tour de France someday. Okay? And you want wallpaper that has a bike rider going. Okay? This direction, I could move it multiple ways. I could move it diagonally. I could move it vertically. Okay? Whichever way I chose. You could also go horizontally, yes. You'd have to go across here. Yep. That would be a horizontal move, yep. Okay, then this one again is a horizontal move. And then some flower wallpaper. Okay. This one again, you can move it in multiple directions. You can move it vertically, horizontally, or diagonally. Okay. Any questions on translations? Translations, just make sure with a translation you tell me the direction and how far. Those two things. And when we do translations, it's going to be on a coordinate plane, so you'll be able to tell me I would move the x 3 to the right and the y 1 down. You can. But I'm going to show you, once we get there, a different way how to write it. Like, when you write a translation on a coordinate graph, you're going to say the x plus 3, because you're going to add 3 to each x coordinate, and then the y, maybe minus 1. It's going to go down. Okay, so this would say, on a coordinate graph, move it 3 to the right and 1 down. Okay, because x goes left and right, y goes up and down. Okay, so the last thing, we're going to look at each of these shapes that kind of got made by the computer. Okay, and you're going to tell me, does it have reflection, rotation, translation, symmetry? Or does it have all three? Does it have just two of them? We have to say. Okay, does this shape have reflection? Yeah. Okay, does it have rotation, symmetry? Yeah. We could rotate it how many degrees? 90 degrees, and it would be the same. Okay, rotating it 90 degrees would mean I would turn this corner to this corner. Okay, and then this corner to that corner. That's 90 degrees. Does it have translation? No, it is not. Okay, the butterfly, does it have reflection? Yep. Does it have rotation symmetry? Okay, what rotation would make it symmetric? Very good, Dylan. 180. I would have to move it 180. So I'm going to take this whole part and I'm going to turn it halfway around. It's going to be the exact same butterfly. Okay? So we could say rotation. Can I say translation? No. Okay? The rabbit that's looking away from us. Okay, does it have reflection symmetry? Yep. Does it have rotation? No. And the only thing you can do is 360, and we don't count 360 as a rotation. Does it have translation? Translation? No. You can't slide it, and it's the same thing. Okay, the kaleidoscope. Does it have reflection? Yep. Not necessarily. Does it have rotation? Okay, what degree would the rotation be in this one? How many times can you turn it? It's going to be the same. 5 times. Because I go here, 1, 2, 3, 4, 5. So I could turn it 5 times. So how do I find the degree measure that the angle of rotation is? 360 divided by 5. And 360 divided by 5 is 72. Okay? A rotation. And that would be 72 degrees. And does it have translation? Yes, I could take a shape and slide it and get the same thing. Okay, very good. So it has all three. Okay, the baby feet. Does it have reflection? Yes, I could draw a line here, fold it over, it's going to be the same. Okay, so it has reflection. Does it have rotation? No. Does it have translation? Yes. Okay, snake. The snake game, I call it this shape, that thing. No. That's where you chase the dots or whatever, and your snake gets bigger. Okay. So, does it have reflection? No. I would say no. Does it have rotation? What would the rotation be? No rotation, I would say there. Okay, translation. Translation is, you could say translation, if you take this shape, slide it over, that's the same thing, right? And I take it again, I could slide it over and I get the same thing. So I would say translation would work in that one. Okay, the think bubble. Does it have reflection symmetry? Rotation? Translation? Okay, this one has none. And the face. Reflection? Yep. Does it have rotation? Translation? No. You could only say translation for what? The eyes. That would be the only thing. But because it doesn't work for the whole shape, I would not put translation down. Okay? Any questions today? Okay, so then your homework is H1 worksheet. You're going to want to look at, I think it talks about different types of reflection lines and how many lines of symmetry shapes have. Okay? Just make sure you do the front and the back, I believe. Front and the back. Yes.